Assalamualaikum warahmatullahi wabarakatuh. Today we will go through the analysis of regression models on diabetes progression. I used the diabetes dataset containing 442 patient records. As shown in the left image, there were 0 missing values. The descriptive statistic table on the right confirms that the input features are already standardized, while the target variable represents the quantitative measure of disease progression. I established a baseline using a multiple linear regression. So while it achieved an accuracy of 45% here, compared to the simple linear regression, only 0.23 meaning 23%. So multiple linear regression, we have an accuracy of 45%, but the coefficient reveal a problem. As you can see in the result, S1 here, the below one, and the S2 here have a massive opposing values, suggesting the model is struggling with correlated features and potentially overfitting. Okay, to test for nonlinear patterns, I applied the polynomial regressions here. However, as these plots show, the regression line for degree 2 in the middle one and the degree 3 on the right one look almost identical to the straight line on the left side. So the accuracy did not improve. As you can see, the R squared did not improve, over around 0.23 for a single feature. So this one, it's proving that the relationship is linear, and adding complexity just add the noise and unnecessary. Okay, so since the complexity didn't help, I used the regularization as the solution to fix the instability found in slide 4, which is the huge massive opposing value for the coefficient. So the table here shows the result for linear regression, ridge regression, and also the lasso regression. For the ridge, it shrank the S1 and S2 to the smaller stable numbers. If you can see here, S2 previously in linear 518, in ridge it reduced to 86. Same goes to S1, negative 931 reduced to negative 108. So this one is the huge reduction. So it will affect the stabilization. And then for the lasso regressions, it successfully zero out the redundant feature like the S2 here, 0, and also the S4 here. So it basically is simplifying the models. Okay, so we come to the final model comparison between the linear regression, polynomial, ridge, and also the lasso regression. So this visual comparison confirms our finding. The lasso model in the bottom right corner shows the tightest clustering around the red radiation line. In contrast, the single feature polynomial model in the top right shows the significant scatter, confirming it's too simple for this task. The lasso regression is the best model for this dataset. As shown in the summary table, it achieved the highest accuracy, 47%, which means the R squared is 0.47 highest, and the lowest error RMSE 52.92, the lowest compared to the other, like the polynomial, ridge, and also the linear. So it succeeded because it filtered out the noisy variables, creating a robust and generalizable model. Okay, so we come to the limitations. Finally, study was limited to the small data set size, which is our size is the 442, is small for the clinical generalization. And the polynomial regression was limited to only one feature due to visualization constraints. And then for the feature improvement would involve collecting more data and testing a nonlinear algorithm like a random forest. Okay, so that's all for the analysis of regression models on diabetes progression. Thank you.